Welcome back to the final exam review examples part A. This time we're going to look at the B problems. So starting with the first one, scale factor of figure X to figure Y. So that means when they're looking at this, they are always putting figure X in the numerator and Y in the denominator. X to Y is 1 to 7.5. So that means 1 to 7.5. It's going to equal, find the perimeter of figure Y. My perimeters are 15 in my up arrow, and I don't know in my down arrow. That's what I'm trying to find. And then I'm going to, just like in my example problem over here, I'm going to cross multiply. 1 times X and 15 times 7.5. 1 times X is just X, and 15 times 7.5 is 112.5. There's my answer. Let's look at 2B. 2B is just like 2A. Notice the pictures are almost identical, just kind of pointing a different direction, and my numbers are different. Over here I said, okay, these are both 5 because I've got 10. So on my next example, if all the way across is 22, then these are both 11. And then I was looking for this leg of a right triangle. So my leg equals the square root of 15 squared minus 11 squared. X is that leg, square root of 15 squared minus 11 squared gives me 10.198 units. All right, let's look at 3. 3, an anchor line for a tower needs to be replaced. The tower is 96 feet tall. The anchor line is 100 feet long. How far away from the tower will it be placed? So I'm trying to figure out what this distance here is. And just like over here, I know we are allowed to assume that construction is done well and my tower is standing up straight. So I can have a 90-degree angle there. And just like in the last problem, I'm looking for a leg. So I'm going to solve it exactly the same way. My hypotenuse is 105 minus my other leg, 96 squared. So I need to place that leg, or the bottom of the anchor line, needs to be placed, second square root, 105 squared, minus 96 squared. I need to place it 42.532 feet away. Okay, let's look at 4B. Find the value of X. Make sure your calculator is in degrees. I have not closed my calculator since I looked at the last video, so I can see it is still in degrees. I'm going to be looking at SOHCAHTOA. The angle that I know that I'm going to put my smiley face at, here it was 57. Here the angle I know is this 50.1. Coming out of that angle is my hypotenuse and my adjacent side. My hypotenuse is across from the right angle. The adjacent side is 5. And then the side that's left is all the way on the opposite side. We call it the opposite side. I'm trying to find that opposite side, and I know the adjacent side. So this time I'm going to use not sine like last time, but tangent. Tangent of the angle is 50.1 equals opposite over adjacent, x over 5. And then I can see over here, the next thing I did was cross multiply. Put this side over 1 so that I can cross multiply, and I'm going to get x times 1 equals 5 times the tangent of 50.1. Okay, now in this last example, I had x times the sine of 57. Here I've already got x equals, so I can go straight to my calculator. So the problems are similar in solving and setting up, but a little bit different in solving. 5 times the tangent of 50.1. Notice it opens up the parentheses for me, so I should close them. Put that seatbelt on. and I get 5.979, but then that's going to bump, right? So really it's 5.98. If I really wanted to show that I was rounding to 3 places, I could put a 0 on the end there. That would be fine. And it doesn't have units, so these are just units. Okay, let's look at 5b. We are still in degrees. We are doing this time inverse trig. Look at my last example. So katoa. The angle I'm trying to find is angle A. That's where my smiley face goes. So out of there comes a hypotenuse and an adjacent side. The hypotenuse is across from the right angle, so that means this one is adjacent, and the one we're opening up to all the way on the opposite side is the opposite side. I know my adjacent is 6. I know my hypotenuse is 10. So this time I'm using cosine, but remember we're trying to find the angle, so we're going to use inverse this time. So the inverse cosine of adjacent over hypotenuse is inverse cosine of 6 over 10 is going to give me my angle to the nearest degree, whole number. Inverse cosine, second cosine, of 6 divided by 10 to the nearest degree is going to be 53 degrees. Okay, let's look at 6b. Okay, if I look at 6a for comparison, I can see we use the idea of alternate interior angles being congruent. So let's see if I know the alternate interior angle to x. If I come across this transversal, the alternate side is 42. So yes, x equals 42 degrees. Easy peasy. All right, let's look at 7b. True or false, consecutive sides in a rectangle are perpendicular. So that means sides next to each other intersect at 90 degrees. Let's look at a rectangle and see if that is true. Okay, so if I were to draw a rectangle, if it's a rectangle, I know my angles here are 90, so I do have perpendicular intersections, but are they the consecutive sides? Remember, consecutive means next to. Okay, so for example, if I look at a vertical side, the consecutive side would be one that was horizontal right next to it. Well, yeah, that intersects at a 90. Those are perpendicular to each other. Okay, but what if instead of that one, oops, I didn't mean to erase the whole picture. Let me get that back. Boop. Get my rectangle back. Come back, rectangle. Okay, well, maybe I'm not looking at the top. Maybe I'm looking at the left side and the bottom. Do those intersect at 90? Yeah, they do. Those two are consecutive and they are perpendicular. So that seems to work. There we go. I keep erasing my whole thing. Okay, what about if I do the right side? Is that also going to give me perpendicular intersections? So what if I'm looking at this side and let's say the bottom? Those are consecutive sides. They're next to each other. Are they going to be perpendicular? Well, yes, they are. Okay, so those are perpendicular. What about the left side and the top? Right? Are those perpendicular? Well, yeah, those are perpendicular also. They're consecutive, they're next to each other, and they're perpendicular. So this is a true statement. It doesn't matter which two consecutive sides I choose, their intersection is always going to be 90 degrees. So consecutive sides will always be perpendicular. Okay, let's look at 8b. For the isosceles trapezoid, find x. And this picture looks very similar to this one, just upside down. And instead of a 22 and a 45, I've got a 25 and a 38. And then I'm looking for that x. So I know I'm still going to be looking at that same type of thing that I was looking at before, where I was looking at the triangle here. And I know that the angles in a triangle have to add up to 180 degrees. And I already know that this corner has 25 and 38 degrees in it. And this corner matches with this bottom piece. So these two pieces both have 38 in them. So far, I've used 25 degrees plus 38 degrees plus 38 degrees. I've used 101 degree. So what's left for this angle here? 180 minus 101. I have 79 degrees left for that bottom angle. So this whole angle, my 25 plus my 38, this angle and the third angle together have to make 180 degrees. Okay, let's look at 9B. Okay, for 9B, again, it's just like the last one, the one next to it where I can see I marked that I have a top and I marked that I have a tail. And I said my side angles are the same. So if one is X, the other is also X. They're the same. And then let's see, what did I do? I added together the 110 and the 22, so my top and my tail angle. 115 plus 31 gives me 146. And then I took the 132 I got last time and I subtracted it from 360 because all the angles in a quadrilateral add up to 360. So this time from the 360, I'm going to subtract the 146, which leaves me with 214. When I divide that by 2, I get 214 divided by 2 is 107. So each one of those angles is 107 degrees. Okay, let's look at 10B. The figure below is an image that has been translated using the coordinate notation xy is from x minus 3, y plus 2. What are the coordinates of point S in the pre-image? So again, I'm looking for the pre-image, which means I'm working backwards. So originally, x minus 3 means I moved left 3, and then y plus 2 means I moved up 2. But I need to work backwards because this is how I got here. Where did I come from? So instead of going left 3, I'm going to go right 3. And then instead of up 2, I'm going to go down 2 to find where S should be, because x minus 3, y plus 2 minus 3 plus 2 gets me to that S prime. So S should be the point -1, -1. Okay, let's look at 11A. Reflect the figure below across the line y equals -x. So when I look at y equals -x, it's different than over here, right? This time I'm a little bit different because I'm reflecting across not y equals x, but y equals -x. So that is this line here that I'm reflecting across this time. So that means I'm going to have a different rule. XY is now going to, let's see, y equals -x, xy reflects to opposite of y, opposite of x. Opposite of y, opposite of x. Okay? All right, so let's take one point at a time. If I start with this upper point right here, it is at 5, 6. So that's going to become the opposite of y is -6. The opposite of x is -5. -6, -5. Okay, then let's move here, which is at 3, 5. So 3, 5, the opposite of y is -5. The opposite of x is -3. So -5, -3. Okay, then let's keep moving around to this point here, which is at 2, 3. The opposite of y, -3. The opposite of x, -2. -3, -2. And keep moving around. Here I've got 4, 1. 4, 1. The opposite of y is -1. The opposite of x is -4. -1, -4. Okay, and last but not least, this point here, which is at 6, 1. The opposite of y is -1. The opposite of x is -6. -1, -6. So here is my new image. Pretend that's a straight line. All right, there we go. I have been reflected across the line y equals -x. Okay, let's look at 12b. If S for -1 is rotated 270 degrees, what are the coordinates of S prime? Now this one, we can't do exactly the same as the last one because just like on 11, I'm rotating by a different number of degrees. So I am going to have to go and refer back to the formula chart. For rotating 270 degrees, xy rotates to y, the opposite of x. xy rotates to y, the opposite of x. So if I am at 4, -1 for my s, then s prime is going to be at y, -1, the opposite of x. The opposite of 4 is -4. So s prime is going to become -1, -4. Okay. And last but not least, number 13b, given a radius of 7, find the length of UPQ. So I do have a formula over here for finding length of an arc. My length equals the measure of the arc over 360 times 2 pi r. The measure of the arc, UPQ, I start at U, I end at Q, and I have to travel through P. So UPQ is here. Okay, so I can see I'm rotating around 40 degrees, and then I continue another 90 degrees. So that total arc there is 130 degrees. My 40 plus my 90, 130. Okay, so my length is 130 out of 360 times 2 pi, and then my radius is 7. 130 divided by 360 times 2 times 7. Math, let's make that a fraction. 91 over 18 pi. And I don't know my units, so I'm just going to say units. As a decimal, times pi gives me 15.882 units. There we go. Our exact answer and our approximate rounded answer. All right, if you have any questions over any of these problems, 1 through 13 on part A, make sure you're asking during sync time, if you're in person during class time, or if you are online after sync time, stay in for tutoring. All right, thank you so much for watching. I'll see you in part B.